All right, we're looking at lesson 2425, dealing with segments, midpoints, and bisectors. We'll start with the midpoint of a segment. The midpoint of a segment is a point on a segment that is equidistant from both endpoints. And if you haven't heard the word equidistant, it is what it kind of sounds like, an equal distance. So a point on a segment that is an equal distance from both endpoints. If we fill in the blanks here, it says a point is the midpoint of a segment if it is equidistant. If it is equidistant from the two endpoints. This means the distances from this point to each endpoint are congruent. And the symbol for congruent, it looks like an equal sign with a little squiggle over the top. That is your congruent symbol. If you look at this example right here, we have line segment PQ, and point M is the midpoint. Point M is the midpoint of line segment PQ. Now, how do I know for sure that it's the midpoint? It looks like it's in the middle, but how do I know for sure it's in the middle? That's what these marks right here do for us. These are called tick marks or congruency marks, and we put those marks on segments when they're congruent. So when they mark line segment PM with this mark, and they put this mark on line segment MQ, they put the same mark on two things. They're saying that those two things are congruent to each other. So if this segment and this segment are congruent to each other, that means M is right in the middle, which makes it the midpoint. All right, how can you find the midpoint of a segment that is on a number line or a coordinate plane? Let's start with the number line. Here is the formula. And in this formula, A and B are coordinates of the endpoints. So if I know what the coordinates of the two endpoints are, I can take those numbers, those coordinates, and I can plug them into this formula to find the midpoint. Now, if you know much about averages, you'll recognize that's all we're really doing. We're finding the average of those two coordinates. We're adding them together and dividing by 2. Remember, when you find the mean or the average, you're just adding them all up, and you're dividing by however many numbers you added up. Well, since a segment only has 2 endpoints, we're adding 2 numbers together, so we divide by 2. So it's really just an average. So if you understand how average works, how mean works, then just do that. If that's not something that's stuck in your head real well, then here's your formula. Just refer back to the formula each time. So on example 1, find the coordinate of the midpoint of line segment FG. So here is point F at -3, and here's point G at 3. Those are our 2 endpoints. So as far as our formula goes, these are our A and B. So we're doing A plus B divided by 2. A plus B divided by 2. I add the 2 endpoints together, divide by 2. So -3 plus 3 is 0, and 0 divided by 2 is 0. So the midpoint would be right here at point 0. That is perfectly in the middle between points F and G. It is the midpoint of line segment FG. Okay, let's do the same thing on example 2. Find the coordinate of the midpoint of line segment AB. So here's point A, and this is at the point -3.5. Okay, it's halfway between -3 and -4. And then B is 3. So those are our 2 endpoints, -3.5 and 3. So I'm plugging those in the formula. I'm just averaging them. I add them together, and I divide by 2. So -3.5 plus 3 is a -0.5. And -0.5 divided by 2 is a -0.25. So the midpoint is going to be at the coordinates -0.25. Now, here's 0. If we go negative, we're going to the left. This is -0.5. -0.25 would be halfway between 0 and 0.5. So right there, that's where our midpoint is, at -0.25. All right, example 3 is going to be a little bit different. It says if the coordinate of the midpoint of segment AB on a number line is 3, and A is at -2, find the coordinate of B. So on the past couple problems, they've given us the two endpoints, and we had to find the midpoint. This time, we already know the midpoint. The midpoint is 3. That's the midpoint. And we know one endpoint, A is negative 2. We're trying to find the other endpoint. So let me just draw what that would look like. You have line segment AB. M is the midpoint. They told us that the coordinate for the midpoint is 3. The coordinates for A, negative 2. And we are trying to find out what is the coordinate for point B. Now there's a couple different ways we can go about doing this. One, you can use that formula where the midpoint is equal to A plus B divided by 2. And we can just substitute in everything we know. So we know the midpoint is 3. We know A is negative 2. What we don't know is B. So once we've substituted in everything that we know, there's only one variable left in that equation. We can solve that equation. So we just go about solving for B. So first thing I want to do is I want to get rid of this 2 down here since everything on this side is being divided by 2. I do the opposite operation. I multiply by 2 to get rid of it. And I need to do the same thing to the other side. So 2 times 3 is 6. Over here I still have that negative 2 plus B. So then I want to start getting B by itself, which means I need to get rid of this negative 2. Since it is a negative 2, I need to add 2. I'm doing the opposite. Negative 2 plus 2 is 0. It's gone. So all I have left is B. Now if I'm adding on one side of the equation, I need to add the same thing to the other side. 6 plus 2 is 8. Alright, and there's our answer. Alright, now I do believe that there is an easier way to do this. So it can be done through the formula just like I showed you, but I think there's an easier way. Understand that the midpoint is right in the middle of this line segment. These two segments are congruent, so M is exactly halfway from A to B. So whatever the distance is from here to here, it's the same distance from here to here. So let's look at our numbers and see what is that distance. From negative 2 to 3, what's the length of this line segment? What's that distance? To get from negative 2 to 3, we are adding 5. This segment has a length of 5. So if this segment has a length of 5, this segment over here is congruent. It's also going to have a length of 5. So from 3, I add 5, and we would end up at 8. And there's the coordinates for your other endpoint, point B. Okay, so all of that was dealing with a number line. We were in one dimension. Now we're going to move to a coordinate plane. Now we're dealing in 2 dimensions. And here is your formula for midpoint. Okay, if this is the first time seeing it, it might look a little complicated to you, but I assure you it's not that bad. If we just focus one thing at a time here, if I look just at the x's, this should look pretty familiar to what we just did. Our formula was A plus B divided by 2. Once again, we are adding 2 numbers, dividing by 2. If we focus on the y's, again, A plus B divided by 2. The only change is, a minute ago we were on a number line, we were doing 1 dimension. Now we're on a coordinate plane, we're doing 2 dimensions. So basically we're doing the exact same thing, we're just repeating it. We're doing it once for the x coordinates and once for the y coordinates. You just have to do it twice because you have 2 dimensions. So it's really the same process, just doing it twice. So let's look at example 4. Find the midpoint between negative 10, 3 and 8, negative 7. First thing I'm going to do, we got a graph here just so I can help you see it and hopefully understand it better. But we could do this with just the formula without the graph. But let's throw these on the graph real quick. Negative 10, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. So there's negative 10, 3. And then 8, negative 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. There's 8, negative 7. So there's line segment. There's the line segment connecting those 2 endpoints. We want to find the midpoint of that segment. So with a graph, you might be able to kind of get a general idea just looking at it where it might be. On the graph though, let's just count from one end to the other how far we'd have to go over and up and down, and then we'll travel half of that distance and it would put us in the middle. If you travel exactly half the distance, it will put you right in the middle at the midpoint. So how far is it from one end to the other? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. over 18, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I went across 18 and I went down 10. So that's how far I had to travel to get from one end to the other. If I want the midpoint, right in the middle, I want to go half of that. So half of 18 would be 9, and half of 10 would be 5. So if I go over 9 and down 5, I'll be exactly halfway across. I'll be at the midpoint. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. Right there. There's where the midpoint's going to be. So let's look and see what those coordinates are. -1, -2. Oops, -2. All right, let's see if our formula will give us the exact same answer that we got by just doing it on the graph. So when we look at our coordinates, every ordered pair, the first number is x, second number is y. First number is x, second number is y. Okay, now there's x1 and x2 because there's two different x's here. One is going to be x1 and one's going to be x2. Okay, it really doesn't matter which one's which, but once you have identified x1 and y and x2, make sure that y1 comes from the same point as x1. Make sure y2 comes from the same point as x2. So there's our coordinates. So let's just take these numbers and plug them in where they go. So x1 is -10, x2 is 8, and that's what I need right there to find my x coordinate. Y coordinates, y1 is 3, y2 is a -7. And again, all we're really doing is averaging. Averaging the x coordinates, averaging the y coordinates. So, simplifying this one right here, -10 plus 8 is a -2, and -2 divided by 2 is a -1. 3 plus a -7. When you add a negative, you're really subtracting. So we're doing 3 minus 7 is a -4, and -4 divided by 2 is a -2. And you should notice that we got the exact same thing doing the formula as we did by plotting the graph and doing a bunch of counting. So this point is right in the middle of this segment. It is the midpoint at -1, -2. All right, let's try another one. Find the midpoint between point V and point W. All right, this time let's do the formula first. So this is x1, y1, and this is x2, y2, and I want to plug them into my formula for midpoint. So, averaging the x values. I'm going to add the x values together and divide by 2. x1 and x2 divided by 2. Then I'm going to add my y values together and divide those by 2. So -6 and 2 are the y values. I add those together, divide by 2. So, for x, 3 plus 7 is 10. 10 divided by 2 is 5. For the y values, -6 plus 2 is a -4. And -4 divided by 2 is a -2. All right, let's see if that makes sense on the graph. If I plot the point 3, -6, 1, 2, 3, 1, 2, 3, 4, 5, 6, there's point V. And I plot the point 7, 2, 1, 2, 3, 4, 5, 6, 7, 1, 2. There's point W. So there is line segment VW. Now, based on our formula, we said that the midpoint should be at 5, -2. Let's see if that makes sense. 1, 2, 3, 4, 5, -2. Right there. There is our midpoint. And if you want to check to see that it's the same distance here and here, let's just count from V to M. 1, 2, 3, 4, 1, 2. Up 4, over 2. 1, 2, 3, 4, 1, 2. Up 4, over 2. Same distance from here to here as it is from here to here. They are equidistant, meaning this is the midpoint. All right, let's look at the next one. Point M is the midpoint of line segment AB, and it gives us coordinates for A, and it gives us coordinates for the midpoint, and we're supposed to find the coordinates of the other endpoint, point B. Now, let's plot these on the graph. We got the point 0, 1 for A, we got the point 3,5 for the midpoint. And we want to find what the coordinates of point B are. Okay, well, if M is right in the middle of point of line segment AB, then B would have to be over here somewhere. Whatever this distance is right here, it should be the same distance from the midpoint to the other endpoint. So let's just see what the difference is from here to here. How far do I have to go? 1, 2, 3, 4. 1, 2, 3. Up 4 over 3. I'm going to repeat that process. 1, 2, 3, 4. 1, 2, 3. If this was up 4 over 3, this distance right here should be the same thing, up 4 over 3, to make sure that M is the midpoint. So here's B. So now we just got to grab those coordinates. So what are the coordinates of point B? Starting from the origin, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So at the coordinates 6, 9. Now, that's how we do it on the graph. Let's say that you didn't have a graph available to you. It is possible to do this without the coordinate plane. Draw yourself a picture just so you can see a visual. Doesn't matter what the coordinates are going to be as far as how you draw it. Just remember that A and B are the endpoints, M is the midpoint. Alright, if A is 0, 1 and M is 3, 5, we're trying to find out what the coordinates of B are. Here's the deal. Same concept that we just used on the graph. Whatever the change in the x and y values is from one end to the midpoint, we make the same changes to the x and y values to get from the midpoint to the other end. So, if I focus on the x values, from this end to the midpoint, it went from 0 to 3. That is an increase of 3. Well, this distance should be the same as this one, and it should be in a straight line, so it should be going in the same direction. So it should add 3 again. So I'm just taking this number and adding 3. So 3 plus 3 is 6. Then I'll repeat the exact same process with the y value. So the y value went from 1 to 5. Well, that's an increase of 4. 1 plus 4 is 5. Well, this distance and this distance are the same. So if this is an increase of 4, then this should also increase by 4. So 5 plus 4 is 9. And you'll notice we got the same thing that we got right here. So this type of problem is nice when we have a grid. We got a graph to put this on a coordinate plane. But we can do it without one if we need to. We can just draw a little line segment, write your coordinates down, and just see what's the change in x, repeat that change in x. What's the change in y? Repeat that change in y. And that'll give us the other endpoint. Alright, let's look at a segment bisector. A segment bisector can be a point, line, ray, segment, or plane that intersects a segment at its midpoint. So notice it's not too important what it is, it's more important what it does. It bisects a segment. That means it goes through the segment's midpoint. It intersects a segment at its midpoint. So in this example down here, it says that line segment WY bisects line segment UV at Y. So here's line segment YW. This is the segment bisector. Because this is what is bisecting something. Okay? It's bisecting a segment, so it is the segment bisector. Now what is getting bisected is line segment UV. Now if this is what's getting bisected, that means that point where the segment bisector intersects it is the midpoint. So point Y is the midpoint. It is the midpoint of line segment UV. Okay, based on this information, we want to answer these 3 following problems. Now I'm going to use a pencil to mark the picture because I'm using the same picture for 3 problems. I'll need to be able to erase and put new information in. So let's start with example 7. It says if the distance from U to Y is equal to 5, then find the distance from Y to V and the distance from U to V. Well, if we just figured out that line segment UV was bisected it's intersected at its midpoint. Y is the midpoint. Remember, anytime we have that midpoint, I know this segment is congruent to this segment. So if the distance from U to Y is 5, then the distance from Y to V would also have to be 5 because they are congruent. Because Y is the midpoint, it's right in the middle. So the distance from Y to V is equal to 5. Now what is the distance from U to V? So the distance from U to V, this whole thing, well, I can just take 5 and add them together, add those two parts together, and that will give me the distance for that whole. Remember, this is our segment addition postulate, that if a segment is split into parts, those parts are going to add up to equal the whole. So the distance from U to V is 10 units. Okay, I'm going to erase that information from example 7. Now let's look at example 8. If the distance from U to Y is 4x minus 3, and the distance from Y to V is equal to x, find the distance from U to Y and the distance from U to V. Before we can find these distances, we need to know what x is. We're going to have to solve for x. To do that, we need an equation. Well, again, because we know what a bisector is, we know that Y is the midpoint, these are congruent. And congruent means they have equal measures. So anytime things have equal measures, we set them equal to each other. I know that this segment and this segment are congruent. I'm going to set them equal to each other. So I set them equal to each other. Now we're solving for x. I can't have x on both sides. I always get rid of the smallest one. So I'm going to subtract x. So when I do that, I now have 3 x's on this side. Over here, I don't have anything left. So I write down 0. Now I start the process of getting x by itself. I'm going to move this constant. It's being subtracted. So I do the opposite. I add it. So all I have left on this side now is the 3x. And then I'm still needing to get x by itself. It is being multiplied by 3. So I do the opposite and divide by 3. And 3 divided by 3 is 1. So I got x is 1. Now we're not done. The directions didn't ask me to solve for x. They asked me to find these two distances right here. So now that I know what x is, I'm going to need to substitute it back in. So the distance from U to Y was 3x minus 4, or 4x minus 3, excuse me. Since I know x is 1, I substitute that 1 in place of x. When two things are equal, I can replace one with the other without changing the value. I'm substituting 1 in place of x. So 4 times 1 is 4, and 4 minus 3 is 1. So it just so happens that the distance from U to Y equals 1. Now if the distance from U to Y is 1, then the distance from Y to V would also be 1. So then what would the distance from U all the way over to V end up being? It would be 1 plus 1 is 2. So the distance from U to V is equal to 2. Okay, I'm going to erase that information for example 8, and we just have one more to go. Alright, so example 9, if the distance from U to V is equal to 18, find the distance from Y to V. Alright, so the distance from U to V is 18, and we want to know what is the distance from Y to V. Well, if this entire segment is 18, it is being bisected. It is getting split into two congruent halves. That means that each one of these parts has to be exactly half of that whole. So what's half of 18? Half of 18 is 9. So each of these segments will end up being 9. So the distance from Y to V, is equal to 9. Half of that 18.